modern machines, it's more common to use an electronic type of speed sensor and an electrohydraulic governor. In this arrangement, a toothed wheel is fitted to the shaft. An electronic sensor measures the pulse rate produced by the toothed wheel, and from this calculates the turbine speed. The electronic signal is then processed and converted into a mechanical output that then operates the pilot valve in the normal manner. In these governors, the set point and other adjustments are, of course, inputted electronically to the processor. All of these different types of governors still require high-pressure hydraulic oil to actuate the power cylinder and consequently provide movement to the turbine control valves. The same hydraulic oil supply is used to operate the turbine stop valve. One common arrangement is shown here. During normal operation, the pilot valve is open and allows high-pressure oil to enter the space below the piston and hold the stop valve open against the compression of this high-powered spring. In order to close the stop valve, the pilot valve must be moved to the trip position, thereby allowing the high-pressure oil to drain back to the oil tank. As a result of the sudden decrease in oil pressure below the piston, the compression spring slams the valve closed. As we'll see later, operation of the pilot valve, or trip valve as it is known, can be achieved by any one of several alternative means, including a manual trip, a remotely operated solenoid trip, or a trip signal from various protection devices. On reheat turbines, an additional stop valve and control valve are located at the reheat steam entrance to the intermediate cylinder. We get an arrangement here. The reheat stop valve functions in the same manner as the turbine main stop valve, and in fact its operation is triggered by the same trip mechanism. So in normal operation, this reheat stop valve is retained in the wide open position. Steam stop valve. If we wish to trip the turbine under any emergency condition, the trip relay is operated and closes both stop valves immediately. If there were no reheat stop valves fitted, then the large amount of steam that is contained in the reheat piping and reheat tubes in the boiler would continue to flow to the reheat turbine for a short period of time and overspeed. In other words, we would have no control over this relatively large quantity of entrained steam. The reheat stop valve prevents this from happening. Similarly, the reheat intercept valve is fitted to assist in precise control. The intercept valve is in fact a control valve that normally remains wide open, allowing all of the turbine from main steam control valves. However, in the case of a partial load, perhaps due to a transmission line trip, operation of the main steam control valves by governor action may not be sufficient to hold the turbine speed down. Again, this is because of the entrained reheat steam continuing to pass for a few minutes through the intermediate and low pressure turbines. The intercept valve prevents this. Steam control valves and actually starts to close in anticipation if the turbine speed rises to 2% above normal. A similar problem can occur with entrained steam feeding back into the turbine from extraction lines. To prevent this, positive closing non-return valves are installed and arranged to close when the turbine is tripped. The valves are actuated pneumatically but are controlled by a hydraulic trip relay. So we can see that